Yeah. Hi, my name is Phil Gardner. I'm here from CloudFlare from the Austin, Texas office. Thanks for having us. We're here to kind of talk about a project that we've been working on here for the last 6 to 8 months. This presentation was initially going to be by two of our colleagues, Chen and Ajam. They couldn't make it. I've been at Cloud for about 12 months. I'm going to turn it over to Alek right now.
Hello, my name is Alek. I'm Security Engineering Manager at CloudFlare. Until recently, I was based out of the Austin, Texas office, and in August, I actually just moved out here to Lisbon, which is pretty exciting. We're really excited about the office here as a whole, and getting to be some of the first people around is pretty neat. And the fact that B-Sides aligned with it also is super rad. I'm a big fan of B-Sides. I've been lucky enough to be at 6 of them so far in different cities. And we'll just go ahead and kind of dive right in. Before we get started, though, there's one kind of quick slide about what Cloudflare is, and it's kind of important to realize what we're doing in order to kind of understand a lot of the decisions that we made to build a lot of these things internally instead of buying them. And so Cloudflare at its core is pretty large. We have 194 points of presence around the world, serving 100 billion or more unique IP addresses daily. And at its core, we've got 20 million internet properties behind our core offering. And so from a security standpoint, it's a really interesting place to be because we've got a lot of crazy things going on. We offer security products as a company, and so that means at its core we've got a lot of logs, a ton of logs. And this is including production logs. We've got some examples over there, as well as some internal logs, things that you just kind of need to run a business. And a security team as a whole is going to be interested in both of these. You have to be able to put all of these things together and correlate all the stuff that's going on in order to pick out what's actually going on that's not normal, things that stick out and should be investigated by a security practitioner. And so when you have all this data, this is a big question, right? Where do you put all of these logs? There's a pretty traditional answer here. I think anybody who's been on an incident response team would say, well, you put them in the SIEM. It's just what you do. That's how we've always done it, and it works, right? You get data, you can look at the data, you can alert on that data, and you can catch bad things. And when bad things happen, it's easy to kind of trace what happened because all of your logs are there. But we've got a lot of logs. And we're like, okay, why? Why are we putting the data there? It's like, hold up. Is this the right answer? Just because we've always done it that way doesn't mean it is. And in particular, we were thinking while rolling out OS Query, OS Query gives you some pretty interesting logs. There are a lot of differential logs, and so you're not just getting snapshots of what's happening all the time. You have to be able to compare previous logs from a known good state at one point in time in the past to what's going on currently in order to get a whole picture of what's happening. And that's just not easy with a lot of traditional log infrastructure. Beyond that, there's a lot of hidden costs associated with these things. You have to maintain the things that are hosting your logging infrastructure. And I don't know a single security professional who actually wants to get to work every day and update the operating system on a machine and make sure that it's safe. Nobody's super interested in that if they're trying to dig into incident response or a lot of other niche areas of security. And so we took a step back and really just thought about what were we trying to do with all this. And so on the left here you can see we've got all of our log sources, and there's a ton of them. And we kind of narrow that down. We're not, we pick out the important logs and we put those into a place and we ingest them. We're going to enrich those logs and kind of correlate things and make it a little bit more human readable and useful. And then once it's been enriched, we can do all sorts of different types of alerting, right? And then from there, some of those alerts are determined to be false positives and some are not, and we figure out what we want to do with it. Some of these things can be automated away to where a person never has to look at the response, and we just have tooling that does it. Sometimes we need to send a notification to an analyst to look to see if it's actually something that needs to be worked on. And sometimes it just needs to go into some things that we can look at it later. And so we took that diagram and wrote down like a list of real requirements. What is that we need to be able to have in order to accomplish those goals? We came up with a list of things that are pretty hard requirements. Without these, we wouldn't be able to do our job. But then we asked this one other question, like, do we really need servers, right? Do we need to have something like a traditional computer in place in order to do all this work? Because if you look at a lot of the traditional answers to this, like the answer is yes, you have to run a computer in order to do this. But it's just such a pain, and if we get rid of it, it'd make things like really cool, and it seems like a neat idea. And I'm a fan of neat ideas personally, so we added that one to the list there. And it's the only one in a different color because the rest of these we can kind of solve with a traditional answer to this log aggregation and incident response problem. But if we can add that in there, then like we're removing a lot of overhead. We're doing something a little bit neater, and so like this is kind of madness in some senses, but it's also a lot of fun. And so we hopped onto GCP. We were kind of like kids in a candy store to start off with. We're just looking around at all these neat things that exist that don't require the maintenance of an underlying machine, and drew out this crazy chart. There was not a lot of rhyme or reason that went into this. It grew over time. But you can see there's a few things that are really important concepts at the core of all this. You'll see some of these boxes are a little bit bigger than others, like the detection response team down at the bottom. Stackdriver, which is basically a log visualization and searching platform. And then the real like core to changing the actual methodology of approaching incident response and detection response is a message bus, so pub sub inside of GCP. A few other things are pretty important as well, like a SQL database to do correlation and batching over time, and Redis and key store management and source control and a lot of other tidbits. But with that diagram, it's kind of like this, right? How to draw now. The diagram is basically those two circles, and then there's a lot of work that goes into actually building all that. And so really looking at this, it might seem a little crazy, but it's not. It doesn't look unwieldy until you pick like one of these pipelines. And so just that one pipeline right there it gets a lot more complicated when you actually start to integrate it and build it out and turn it from a line on a diagram into actual like working code. And so we took another step back after we explored these kind of serverless options a little bit. And really looking at this, you can kind of tell it's a big data flow, right? It's a funnel, taking a lot of things and turning it into only the things you care about. And so after revisiting it a little bit, we ended up with this. And what this really kind of represents, you can see on the left, it's a lot more similar to that previous diagram, where we've got a bunch of log sources on the left that are all being ingested in with various functions, and then pushed into pub sub topics in the middle there, getting enriched, and then we've got a nice little bit of alerting down at the bottom, and then we've got a bunch of notifications on the end. And so there's a lot to kind of digest with this diagram, and I quickly went over things kind of intentionally, because I'm going to turn it over to Phil to really pick one of these flows, starting with one log source and going from the actual source of a log all the way until we get to a notification to the detection response team.
Yeah. Thanks. Yeah, so basically we're just going to pick like one of these log types that we have and kind of work through how it might go through the pipeline here. But just because there's like a lot of like various implementation details that aren't really that important. So for instance, this is basically what a event flow from one of our core light sensors looks like. If you're not familiar with it, core light is the commercial version of Zeek, which was formerly known as Bro. So kind of look at this, the first sort of third of this diagram is like, how do we get events that are streaming from core light sensors into GCP in general? And kind of a better question is, how do we do this for a very large variety of log sources? We kind of have to support lots of different ways to ingest data. We could pull directly from like a SaaS API, or maybe the Producer could just write directly to a GC bucket. There's lots of different ways. In the case of Corelight, we actually deployed a cloud function that fakes an Elasticsearch API and then will write all the incoming events in a batching manner to a Cloud Pub sub topic. Here's kind of like a different way to sort of look at how we get data into the pipeline. Kind of like what I mentioned, we don't want to be too draconian as far as what the implementation details are, but we do have to sort of standardize on a couple of pieces here. Probably first and foremost is every event we want to have written into a Cloud Pub sub, which is, if you're not familiar with it, it's basically a message broker that's like Kafka. And a cool thing about these pub subs is that you can have multiple subscribers, including these, what they call background cloud functions that will basically fire off every single time a message enters the queue. As well, we wanted to be able to actively search these logs. And I think Alek mentioned this as every event gets written right to Stackdriver, which is essentially like a Kibana-like front end. It's got an automatic parsing of JSON and protobuf messages, and probably the big key for us is that it's free to search. You get free 30-day retention, and you're basically only paying for the API rights. So once we have all the events sort of coming in, we need to start interrogating our data, right? There's lots of different types of questions we want to ask. Does this event match some known signature? Is there some known threshold that this metric, for the metric that has increased, or maybe is this an event that's indicative of some kind of, newer or anomalous behavior? Maybe there's a sudden increase to DNS queries to some Russian ASN or something, who knows? Lots of different things. We kind of thought about this in sort of three different types of techniques, right? Which we'll basically break down into three different types of sort of rule engines, if you will. We've got a real-time or tripwire or signature-based, things like, is this a malicious JA3 hash? Is this a known typo squatting domain? This is all powered by Google Cloud Functions. And then I say three-ish because this next one is more, these next two methods are very similar, right? It's very batching and time-based, right? And these are, how do we query a bunch of event across either multiple log sources across a various time period, or, using some kind of ML stuff. This is all powered by BigQuery, which is essentially, a very Google SQL-like product. We haven't really done too much on the anomaly stuff. That's going to be coming more in 2020. So I won't go over that too much. But we're just getting started with that. Anyway, so first up, the real-time rules or the tripwire rules, as I mentioned. These are all cloud functions that we wrote in Golang. Every single message that comes into PubSub triggers an invocation. These are wicked fast. We're doing about 60 milliseconds on the average of execution time. And then Golang is just really nice. It gives us Go routines, which lets us do a lot of different things with each message because of its easy concurrency. We have about 30 or 40 different cloud functions right now that handle a bunch of different events coming in. And these are all, the vast majority right now are written in Golang, but we started kind of playing around with this new rule engine called the Common Expression Language that Google recently released. This is the same sort of engine that powers GCP IAM policies, Firebase IAM policies, also some Kubernetes things. But you can see this is a lot easier to write than, a bunch of boilerplate for Golang, which makes it really easy for analysts to write sort of understandable rules very, very quickly without needing a huge, deep developer background, which is a pretty important part of a traditional SIEM. Next up are what we kind of term batch rules. These are sort of more complex queries that we can interrogate events across multiple time periods, multiple data sources, but probably primarily the most important thing is with a sort of standard SQL syntax, right? So basically every single event is written to BigQuery automatically once it's written to Stackdriver through something called a export sync. This saves a ton of time because we don't have to do any work at all. This is just writing a filter that says drop everything into BigQuery. Then we write rules in a predetermined sort of YAML config, load it up through a couple of cloud functions that basically write these scheduled queries, and then we'll run them on the schedule. And then if any of those rules match, we'll basically put them down at the pipeline the same way as the real-time alerts. So you can see here's like a pretty simple batch rule that one of our team members wrote. We're setting like the frequency, how often it should run, what the name is. It goes right to a playbook. I'll go more into the playbooks later. But yeah, you can see probably the most important part of the query there is just pretty much standard SQL. Yeah, so anyway, once let's say we triggered a rule, we basically need to respond to it somehow. First and foremost, we publish this again to a cloud pub sub. This is a pretty common thing that we're doing without the pipeline. It basically gives us a lot of lag time and the ability to handle these events in multiple different fashions from sort of one ingress point. This also includes false positives coming in there, so we can like either discard those or verify them further by another cloud function down there. Same thing with like duplicate events. The last thing you want to do is something that we've seen a lot is somebody isn't able to log into Okta. They have like tons of multi-factor authentication failures, and it's really just the same sort of incident, if you will. So we can sort of handle that in the queue. Right now, we just have one function that we call sirens. It's basically a lightweight alert router. Pulls every single message from this raw detections pub sub, and then based on what the standard alert format is, it'll route it to either PagerDuty or Jira or Google Chat. We plan to have a lot more subscribers, things like Chronicle and whatnot. But like I said, we're still in sort of like pre-alpha phase here. Anyway, so here's a quick match of like a Google Chat notification here. You can see it took like 15 seconds. One of our team members was playing around with the Merlin C2 framework. But yeah, it was pretty quick. That's kind of a nice brief overview. We've kind of learned quite a bit. Has this project been worth it? I'd probably say so. This is definitely our primary detection response pipeline right now. We are currently pushing around 2 to 3 terabytes a month. We're probably estimating to grow to 50 to 60 terabytes for the next year. And probably the coolest part is half the cost is just writing to Stackdriver. The invocations of cloud functions, we're talking hundreds of millions of invocations per week or per month is dirt cheap, a couple $100. This is about 50 times cheaper, from some of our back of the hand math than a traditional SIEM. And we definitely have a ton more to build, as you can see, but it's not 50 times more expensive to build what we're about to build. Some future plans, way more log sources coming in. We want to add a couple more correlation rule types, things like, is this a spike? Has the frequency changed of these sort of queries? Probably want to look at a lot more. Sometimes when I think about, what does our sort of detection posture look like? It's like, do we want to do a lot more correlation, which is signature based, or do we want to sort of model what does this asset look like? What does this human sort of behavior look like? So we're going to investigate a lot more. A lot more data analysis tools. Google has a ton of really, really cool integrated ML tooling. We're definitely hiring for that right now. So if you're interested, feel free to talk to us. And then integrating a lot more enrichment of events with a bunch of threat intel databases. And because of our scale, we have just all sorts of crazy data available to us. Another cool thing that we're looking at is automating playbooks through basically Jupyter notebooks, which are Google has a hosting thing like that as well. But essentially, Jupyter notebooks, if you're not familiar, are a way to sort of contain live code and documentation and visualizations all in the same document. This would let us, save tons of time on the response side because, maybe 70, 80, all of the response playbook could be done by the time a human actually looks at it. It's pretty cool. I'm pretty excited about that myself. You want to talk about this?
Yeah, so this is just kind of a quick aside to kind of wrap things up a little bit. This graph represents about a week where we were initially testing and sending data in. The bottom line where you can see there's almost nothing, we were pushing about 20 gigs a day. It was a singular log source from a portion of a set of production systems. And the idea was really just to see if this even worked. And we felt pretty confident that it was going to work. We were like, okay, let's add another log source and see just what happens. And without really thinking about it too much, we turned this log source on a Friday afternoon. And that peak there is 9.1 terabytes. And so we went from a system that was designed to accept around 20 to 50 gigs a day to accepting 9.1 terabytes a day. And the really like super cool part about this is we didn't lose a single piece of data. And like we didn't end up with a bill that we couldn't pay. And so we had all the data from this source that was pushing 9.1 terabytes, pushing to a system that we hadn't even tested a fraction of that on. And it just all worked. And so, that was kind of one of the like biggest, accidental wins I think that we accomplished here. And, it was just really exciting to come back on Monday and see this graph and then promptly turn it off because that was not what we were looking to do. So we have just about 5 minutes left, which is pretty good timing wise. It's what we were aiming for. So if there are any questions that anyone has.
Okay. Hi. Great presentation. Just a simple question related to BigQuery. It's a structured database. How do you cope with adding more sources and events that have multiple fields? And the second question is, have you looked into Chronicle, the cloud SIEM from Google? Thank you.
So second question first. Yeah, we actively use Chronicle. We're working with Google as well to sort of provide them with a lot more log sources to ingest into Chronicle. It's definitely going to be interesting to see what happens with all the news recently. But as far as the BigQuery, so when you create this export through Stackdriver, it will actually automatically update those fields as long as they're just new. We have had some issues where somebody had added or one of our initial models of a data source was essentially an int, right? And it was actually a float. And so that would cause some issues. We have to like drop the table or whatnot. But in general, it's been pretty easy to, it's not something we have to worry about too often.
I think it's really cool design. Have you tried wargaming against a red team? Like at what stage it would detect an attack? What attack it couldn't detect, maybe?
It's just like every red team did.
So was the question if
have you tried playing against a red team for them to attack and to see at which stage it will be picked up?
Yes. I don't want to go too much into the details of the results of red teaming, obviously, but yes, we have, and the results were pretty neat. That's about as much as I planned. I didn't practice that question. Sorry.
So now we know that Google updates your machines. Who updates the containers?
I'm sorry, could you repeat that, please?
The beginning of the presentation, you said you don't want to update operating systems on the machines. Who updates the containers?
Yeah, so I think to expand on that a little bit more, like inherently the people like to throw the word serverless around, but what that really means is someone else is running the machines. And the approach that we were really trying to take here is, can we offload some of the operational workload from our security team? Because if we couldn't, then we would have to start hiring SREs and ops. And if you look at a lot of the cloud providers, be it Google, Amazon, Microsoft, or even CloudFlare itself, like we have what we call a serverless offering as one of our products. The idea is not to claim that there's no operating system or machine underneath. The idea is to remove that overhead from the people using the platform. And so that's kind of what we were aiming for there.
That said, Terraform's doing a lot of work for us, and we have a very robust sort of CI/CD system that'll deploy and roll back functions and test and all that. So that was something we wanted to incorporate very, very initially to make sure that's part of our DNA when building out this project.
Any more questions? I don't think so. So, Phil, Alex, thank you very much.
Thank you.